Good morning, students. So we'll move on to the next topic, that is interface circuit. Fine. So while discussing about the accessing IO device, which was the first topic of module number 2, computer organization. Fine. So then we were having a rectangle. We are naming it as what, interface circuit, right? So inside that interface circuit, we got three different modules. The first one we call it as address decoder. Second one we called it as control circuit, and third one data circuit or data and status register, right? So we need to go in deep regarding this interface circuit. Fine. Okay. So now we'll see what exactly interface circuit stand for. An I/O interface consists of the circuit required to connect an I/O device to a computer bus. Fine. So whatever the connection we are expecting for the connectivity of the I/O devices, fine. Okay. So that can be accomplished by interface circuit. That's why we are calling it as an I/O interface consisting of a circuit required to connect the I/O devices to a computer bus. Fine. Remember, the working principle of I/O devices may be different. Okay. And the working principle of our motherboard may be different. Okay. So we need to have some set of a converter. Okay. Who used to convert the data format and the working procedures of I/O devices in a compatible manner of a working principle of motherboard. Yeah. Okay. There are a lot many things job performed by the interface circuit. Okay. So we will be having a glance over a few topics itself. Yeah. Okay. It's a vast like a concept. Fine. So whatever we have in our syllabus, only we are concentrating about that. Okay. So later, second point. On one side of the interface, we have the bus signals for address, data, and control. Okay. So now, up to now, like module number 1 and the half of the module number 2, okay, what knowledge we got is we are having a bus cable. Okay. So internally, it is consisting of a three main line, okay, which is dealing with what address, data, and control. Okay. So that we are calling it as one end actually. Fine. Another end, what we have, another end, we'll be having a devices. Is it right? Okay. Mouse, keyboard, monitor. Okay. If you want to connect using a port, okay. So in the internal end of the port, okay, we may be having a bus cable who is dealing with the address, data, and control exactly. But in the other end, what we have, we are having a devices, right? Okay. So we need to have someone as a mediator who need to manage the IO devices in the one end and the bus cable in the another end exactly. Okay. On the other side, we have a data path associated controls to transfer data between interface and IO devices, which is called ports. Okay. So now, in between the IO device and uh, the bus cable or as those control line. Okay. So intermediate to that, some control circuit we are having associated, which is related to the data path. Okay. That we are calling it as what? Ports exactly. Fine. When it comes for ports, we are having a classification of ports. Okay. There are two main kind of classification. One we call it as parallel and second we call it as serial exactly. Okay. The first one will be parallel ports and second will be serial ports. Remember. Okay. Then later, parallel port send or receive simultaneously. The working procedure of parallel port will be if it is having seven different bit to be communicated, if it is having seven different bit lines, okay, simultaneously seven bit can be transferred. Okay. But in case of serial, we'll be having only one line available. Okay. And if you are having seven different bits, total seven different times, we need to stop the bits. Okay. So in comparison, parallel will be having better performance. Yeah. But what is the condition? We need different number of lines available. Okay. Then only we can achieve the parallelism. Okay. So later, the next is what? So these are the main five job which is listed over here. Okay, which will be performed by the interface circuit. I/O interface does the following. First one provides a storage buffer for at least one word of data. Okay, so the data in and data out buffer registers, whatever we are having. Okay, so this interface circuit will allow us to have at least the minimum, okay, of one word of the data. Okay, so that buffer will be having the capacity, minimum capacity of what? One word exactly. Later, second point. Status flag can be accessed by processor to determine whether the buffer is full or empty. Remember, so these status registers or status flags, whatever we are using to indicate the processor that whether the data is available in the data in or the monitor is ready to display the content. Okay, in both the condition, we are using a S in and S out as a status flags over here, right? Okay, so this interface circuit will allow the processor to access these status flags. Okay, so up to now we were feeling like if data is available, then automatically SN will be set to 1, right? Okay, but it don't happen exactly. Okay, so here we are using a dedicated circuit for this status flag. Okay, when it should rise SN is equal to 1, when it should rise SN is equal to 0. Okay, it depends on around 4 to 5 different input variable or input parameters. Okay, according to that we are going to set Sn is equal to 0 or 1 exactly. So in today's class itself, we will be discussing that. Okay. But like for time being, the interface circuit will allow us to access the sign flags, okay, by the processor example. Okay, fine. Later, third point, address decoding circuit to determine whether it is being addressed by the processor. Okay, so here the interface circuit is consisting of one more module. We call it as what address module or else address decoding module. Okay, so which will allow the devices to decode the referred address. Okay, so if the decoded result get matched with the address of the device, okay, then easily the control signal, whatever is available in the controller, according to that, the device will start behaving. Yeah, so this is also one of the main role played by the interface circuit exactly. Then fourth point, generates the appropriate timing signal required by the bus exactly. Okay, so in case of synchronous bus and in case of asynchronous bus, okay, timing signals are very essential. Okay, especially for synchronous bus. Okay, the bus clock. Okay, what we are calling like within one complete cycle, clock cycle, one data transmission should be performed. Is it right? Okay, in previous lecture we discussed regarding this. Okay, so that is what also the one of the role played by the interface circuit over there. Okay, then later the last role will be perform any format conversion that may be necessary to transfer data such as parallel or serial. Okay, see sometimes the device may be having a working fashion of a serial, sometimes it may be having a working fashion of a parallel. Okay, in that your system is working over a parallel fashion. Okay, if device is also using a parallel fashion, then we don't want any kind of a conversion between them, right? Parallel data will be communicating with the parallel devices. Both are parallel over there. But if the device, the external device, what we are connecting for an input purpose, if it is working with a serial fashion, and if you are laptop or a system or a desktop, if it is working with a parallel fashion, okay, then we need to have some conversion over there. Okay, very simple. We are using a small converter over there, okay, which will convert serial to parallel, parallel to serial over there. Yeah. So these are the very important 5 roles played by your interface circuit over there. Yeah. So now we'll go for discussing about a parallel port. Later we'll go for the serial port. Okay. So here we are considering an example of a keyboard. Okay. So now we will be understanding like if user try to enter some input using a keyboard, how it will be communicated to the processor that data is available, then how the processor will fetch the information. Okay, regarding that we have a complete discussion. So here, like after this, we have a huge block diagram of a circuit. Okay, so there we are mainly concentrating regarding the SIN and SOut. Remember, status flag, whatever we are having. So regarding that, we are having a huge concentration. Okay, so when we go to the next slide, you will get to know. Yeah. Okay, so here we got different components. Okay, see processor we are having. Then this is what the input interface for a keyboard. Okay, so this is what the keyboard exactly. Fine. This is what the keyboard exactly. Fine. Okay. So here we got a key switches. Okay. So whatever the key switches input or the information we are generating using these key switches, that will be transferred to the second phase. What is that? Encoder and debouncing circuit. Encoder and debouncing circuit. Okay. What does this encoder stand for? See, if I press a keystroke of A, okay, the ASCII code of A, it should be converted, right? Okay. So that will be done by your encoder, fine. And later, we are having a debouncing circuit. For what purpose this debouncing circuit works? See, what do you mean by keystroke? Like if you're pressing any key, okay, so that will pop up, right? After pressing also, it is having the ability to pop up, right? Okay. So that states that like how many times you stroke that particular key, okay, once, right? Because of that, you'll be getting a single layer over there. If you keep on pressing that continue, or if you are continuously holding that key for a one complete second, okay, then I hope 6 to 8 different characters, same characters, will be printed over the screen. Is it right? Okay. So now just observe the difference. Okay, so if you are pressing it for only once, if the stroke is for a fraction of second, only once, okay, then only one A you will get. Okay. Then later, if you are pressing the same alphabet or I'll say key for a long period, okay, so there will be a multiple number of the same character displayed in your screen over there. Okay. Why it is for so? Okay, because of debouncing circuit. Here, because of debouncing circuit. Okay. There will be a small time gap, okay, for the keystroke. Fine. If it's expired and if you are still holding that uh, alphabet or if you are still holding that particular key, okay, then this debouncing, okay, debouncing. See, if you are not bouncing, okay, your keys, okay, if you are continuously holding, the debouncing circuit will wait for the expiring of that particular small duration, okay. So after that, if you are still holding, again it will consider as a second time. Later, if you are still holding, maybe third time, fourth time, fifth time, okay. So that you need to break that chain or we need to break that continuity, okay. The starting and elapsing of that continuity, what we are having, right? That small time interval gap between, okay. So that will be splitted, okay. So according to that split, okay, how many splits we are going to get? Those many number of characters you are going to get in your screen exactly. I hope you got right. Okay, debouncing circuit is responsible for reading the particular alphabet or a particular key content, okay, if it is holding for a long duration, remember. Okay, so now after pressing few keys, fine, so data will be available, right? Okay, to be displayed or to be stored. So data will be sent for your data in exactly. Okay, but meanwhile, observe it. Your encoder and debouncing circuit will generate a signal called as a valid. Remember, if data is been transferred along with a no valid signal, then data will be rejected. Remember this. Okay. If you are transferring a information, okay, data to a data in, okay, with a valid signal, okay, means this particular line should be set to 1. Okay. Then whatever you are going to transfer from this particular line, that will be accepted by the data in. Okay. That will be accepted by your interface circuit exactly. Okay. So both are essential. Okay. If you are setting valid is equal to 1, some information should be transferred. Yeah. Okay. So now, with this input valid, okay, your S in will be set to 1. Okay. How it will be set to 1, I will tell you in the last slide exactly. Fine. Okay. We have a separate circuit which will consume the input of valid, consume the input of read bar write, and master ready signal. Okay. With these three different inputs, okay, a circuit will set SL is equal to 1. Meanwhile, data in will be having the content. Like if you are typing AITM or if you are typing your name, anything it may be, Rahul it may be. Okay. So that will be available in the data in register along with SN is equal to 1. So this will be communicated to your processor. Observe it very careful. Okay. You can have a glance of this particular box. Okay. A one module which is consisting of a data and SN exactly. Right. So the data line what we have, okay, towards the processor, right? Out of that one particular line will be utilized to transfer the signal towards the processor. Remember, okay, in next slide you will get to know how it will be done. Okay, so interface circuit is consisting of three modules. Out of the third one will be what? Data and status register. Okay, so both are sharing the same line. Okay, so out of these, see, consider like if you are having using a 8-bit system, okay, 8 different lines you'll be having for the data transfer towards the processor and away from the processor also. So out of that, one line will be used for communicating the sign towards the processor. Okay, this is not dedicated line. Remember, this is not reserved for the SIM. Okay, before the data transmission, this line will be already free. Clear? Okay. So now what we can do, we can utilize this free line to transfer the information, that sign information towards the processor. Now, processor got to know like, yes, there is some data available in the data in. So meanwhile, what he will do, he will just upload the address of this particular device along with the read signal, right? It needs to read the content, okay, along with the master ready signal. Yeah. So once all these three signals being received by the interface or else input interface, okay, after consuming, observe it, after consuming these all signals, the input interface will raise a signal called as a slave ready, called as a slave ready. Remember, the slave ready signal should be active until the end of the data transmission. Okay, if master ready signal, if you are violating or if you are terminating after the generation of the slave ready signal, okay, fine, no problem. But slave ready signal should be always active until the data transmission should get completed. Okay, so later slave ready signal will be generated. Okay, meanwhile, the data which is available in the data in will be uploaded for the data line of the bus. Finally, it will be received by the processor itself. Okay, so this is what how uh, the communication between the keyboard and the processor used to work. Okay, now what we need to do, we need to discuss about this parallel port. Where we have parallel port, here we will be having. Okay, so now this is what very important input interface circuit for the parallel port. You can easily observe keyboard you are having here, data in we got over here, valid signal we have over here. Okay, because of this valid signal, we are having a status flag. See, this is what I told you. Like we are having a dedicated circuit. We got a dedicated circuit for generating the SIM. Okay, so internally we are having a flip flop and we are having a latch kind of circuit that I will explain in the next slide. Okay, so we got a status flag. So who is responsible for generating the SIM? Okay, so here you can observe keyboard is directly having a communication part towards the processor. Okay, D0 to D7 means we are using a 8-bit line, parallel line for communicating the data towards the processor exactly. So this we call it as parallel circuit. Remember, okay, the data path which is available for the communication, okay, whether it is serial or parallel, that we need to observe. Okay, rest of all these kind of working principle will be same exactly. Okay, so now data is available in the data in along with valid signal we are generating. Okay, so after receiving this valid signal by the status flag, see, I told you right, okay, 4 to 5 different inputs are available. See, first one, later, master ready signal. If it is generated, okay, that will also be consumed. Later, read data. Here, read data. Okay, if this signal is available, that will also be consumed by this status flag. Okay, so after consuming all these kind of input, okay, so we are going to generate the SIM exactly. Here, see, whenever we are having a valid signal, SIM will be generated. Yeah, SIM will be generated actually. Okay, but this circuit is utilizing some different parameters over here. Okay, so for what reason exactly? Like it should be working safe or it should be working properly for all the kind of situation exactly, right? Okay, for that purpose we are dependent on many number of inputs exactly. Okay, so now after receiving the valid signals to status and status flag, whatever circuit we are having, that will generate a signal of SIM exactly. See that SIM sign or as SIM flag, okay, will be communicated to the processor using the one of the data line available. Yeah. So this is what the data line. Okay, just compare it with the previous figure. Data line we had. So out of the D0, we are utilizing it to communicate the sign flag towards the processor exactly. So now processor has received the SIM is equal to 1. SIM is equal to 1. So as a response of that, what your processor will perform is, he will just raise a first thing called as a master ready along with the reference address. Okay, address of this particular keyboard. Okay, address of this particular keyboard will be uploaded. Along with that, master ready signal will be uploaded. Along with that, read or write signal will be uploaded over there. And you can observe, we are having a separate line for A0 exactly, right? Here we got a A0. Okay, and from here we have a not, right? For what purpose? A0 determines whether the status or the data register is to be read then the master ready signal is active. Okay, so that is what the meaning of A naught exactly. Okay, forget about this because that will be taking a lot of discussion if we start discussing about A naught, A1, A2, A3 and all. Okay, so A naught indicates that whether we need to read SIN and data buffers or not. Okay, that will be indicated. Fine. So now, after generating all this, see here we are having the AND gates. Okay, I don't want to take the values for this particular AND gate because it will vary exactly. Okay, so it look like a normal line, but internally we'll be having somewhere NOT gates and all. Okay, so now after generating these three signal, okay, so here we are having AND gate and here also we are having the AND gate, right? Okay, so first what we need to do, we need to read the sign. Okay, whether the data still available inside the data in or not, that we need to verify. Okay, how we are verifying using this AND gate exactly. Okay, so the outcome of this AND gate will be what? 1 exactly, right? If you want to read this particular sign, SIN, okay, so from this AND gate we are sending signal called as 1. Okay, so the input for this OR gate, observe it, read status. Yes, we are trying to read the status initially. Fine. Okay, before we start the data transmission, we need to verify whether data still residing inside the data in or not. We need to have a verification. Because of that, first what we do, we are reading the status. Then this line will be 1. Okay, we are not at with reading the data. Okay, so read data line will be 0. We are just verifying whether SIN is still available or not. Okay, then what is the input for this particular OR gate? See, 1 over here, 0 over here. Why? Here, first input is connected for read status, second connected is for read data exactly, right? So 0 and 1 if you are getting, what is the outcome of this particular OR gate? It will be 1 exactly. That is what indicating slave ready. That is what indicating slave ready. Clear? Okay. So when the master ready signal is generated and when the address being referred, okay, so this device will go through the address decoding procedure, which is not mentioned in this figure exactly. Okay. So after analyzing that, okay, and after utilizing these AND gates results and all, okay, using this particular OR gate, the slave ready signal will be generated. Clear? Means the slave is ready to have a data transmission now. Clear? Okay. So after generating the slave ready, okay, we'll be having a switch in these particular values exactly. Okay. So now data is available. So read status will be set to 0. Directly we are trying to read the data exactly. Then this line will be set to 1 exactly. 0 and 1 if you are having, what is the outcome? Okay, 1 it will be. So what is the signal out of this particular gate? Slave ready, 1 exactly. Right. Means until the completion of a data transfer, from the beginning of the reading the status and until the completion of the data transfer, okay, your slave ready signal will be active. Okay, slave ready signal will be active. Previously status was 1. Okay, now status is 0 and read data will be 1 now. Right? Okay. So now so the complete information, whatever which is available in the data in, will be transferred to this particular parallel line, and finally that will be received by your processor. Yeah. So this is how master ready, read bar write, address, slave ready, read status, read data line will be working together. Okay, so that the data which is residing in the data unit will flow towards the processor exactly. Yeah. Okay. So very simple. Fine. But now we'll go through how this status flag, okay, will be working now. Okay, fine. So this is what the internal circuit of the status flag. Okay, circuit for the status flag block. Okay, so this we call it as a flip flop. Okay, so it will be having total 3 inputs here. Okay, clear. Okay, one is input from the read data, not of read, not of read. Okay, if read data is equal to 1, then not we are going to get, then we are not going to reset. If read data is 0, then not of that, then we will be getting a clear signal. Then we are going to reset this particular flip flop over there. Okay, one input from read data, one is the valid, okay, and one is already available. Okay, so you by utilizing all these three, okay, the outcome will be transferred for this particular entity. Okay, so now let me name the locations of this particular, then you will be having better understanding about this. Okay, So I am going to call this particular point as a R, and I will be calling this particular point as a S, the line. Okay, these are the two different lines. Okay, one is the outcome of master ready, and another is the outcome of the read data. Yeah. Okay. So now what we need to do? Okay. See, in the previous slide we discussed if valid is equal to 1. Okay, means if you are receiving a valid information, then automatically we are raising a SIN exactly. SIN is equal to 1 exactly, right? Now we'll see what exactly the consequences we need to get. Okay, so now like S and R. Okay, I'm going to write a truth table, S and R, then here Q and Q dash. Q and Q dash. So this place I'm naming it as Q, and this place I'm naming it as Q dash equal. So whatever the result we are receiving in the Q, that will be the value of S. Remember. Okay. So now, so according to this circuit, I'm writing the truth table over there. If S is equal to 1 and R is equal to 0, if S is equal to 0 and if R is equal to 1. Okay, then what is the outcome we are going to get over here? So 1 we get over here, 0 we are getting. Then later 0 we are getting and 1 we are getting over here. Yeah? Okay. So now, like if you are receiving S is equal to 1, S is equal to 1, okay, then you can observe, easily we can get S, SN is equal to 1 exactly, right? Okay, if you are receiving S is equal to 0, then Q value will be dropping to 0, means SN will become 0 exactly, okay, which indicates, observe it very careful, okay, see, if master is not at all ready, see initially if data is not available, see we need to intimate the processor that this data is available, right? So he will be 0, he will also be 0, right? So not of that, what you are going to get? Not of that, not of that. Okay, what you are going to get? You'll be getting 1 in this particular line exactly, right? So now, if you are available with your data, then valid will be equal to 1. Okay, if valid is equal to 1, see this like flip flop. Okay, what is the outcome and all? I don't want to discuss here. Okay, if you want, you can go through the flip flop topic. Okay, to interact. Okay, then you will be having better information. Like if your valid is equal to 1, okay, then what will be the outcome? Okay, so now I'm considering like if valid is equal to 1, then the outcome of the flip flop will be equal to 1, right? If both are equal to 1, the AND gate result will be equal to 1, means S will be equal to 1, right? When it will be equal to 1, if master is 0, master ready means like master ready signal will be asserted when SN is equal to 1 exactly. Okay, so now what we are considering, master ready 0. Okay, if master is not at all ready for the transmission, then how the read data will be equal to, right? Okay, then read data is also equal to 0. Yeah, okay. So now in the place of S, we are receiving a value called as 1, right? Here we are having a value called as 1. Then we are having a XOR gate over here. Okay, you can go through the truth table of XOR gate. Okay, then here in case of read data, if R is equal to 0, if R is equal to 0, if this is the case, okay, you can go through the XOR gate. Then in this, see the result of sorry, yes, the result of this particular will be provided as an input for this particular OR gate. The result of this will be provided as an input for this particular OR gate, XOR gate. Okay, we are calling it as a latch. We are calling it as latch. This is dependent on another gate exactly. Both are interrelated. Okay, so now if this is the case, if R in the place of R, if it is the value 0, in the place of S, if it is the value 1, so here you will be getting 1 and here you will be getting 0 exactly. It means what? It means SIN will be equal to 1. Indicates what? There is some data available. Okay. Why we are getting SIN is equal to 1? Because here you got, observe it, here you got valid is equal to 1. When valid will be equal to 1, if you are having a data available in the data in register, then only valid will be equal to 1. Right? If I make, okay, fine, let me erase this. I don't want to clear the complete screen. Okay, so I'm going to erase these particular values, the numbers. Okay, and let me take some new values for this. Okay, so that you can have the better knowledge about this. Okay, so feel that master is not ready, Okay, valid is also equal to 0. Okay, read data is also equal to 0. Yeah, all are equal to 0 now. Okay, so master ready, if it is equal to 0, then not of that will be 1. Sorry, yes, not of that will be equal to 1. So valid, if it is 0, here also we are going to get 0 over there. And operation we are having, here you will be getting 0 over here. Here you will be getting 0 over here. Okay, then, okay, so here you'll be having what? Here you'll be having 0 itself. Then, in this particular point, you will be getting 0 and here you will be getting 1 exact. Clear? Okay, because that is how your latch used to work. Fine. Okay, so because of this, Sn will be set to 0 itself. Sn will be set to 0 itself. Remember. So here we have provided one more kind exactly like 0 in case of S and 1 in case of R. In that case also, we are going to get these kind of ripples itself. Okay, so because of this uh, circuit, okay, we are going to set Sn equal to 1 exactly. Sn will be equal to 1 exactly. Okay, so regarding this, in your standard textbook, you have a complete discussion. Okay, so please go through that because I'm not including any theory points regarding these two circuits or sorry, these four diagrams. Okay, previous four diagrams, like one, then two, and three exactly. Okay, so in your textbook there is a complete explanation regarding these three figures. Okay, please go through that. Okay, so in next video, we'll be discussing about an output device. So parallel port, input device we discussed regarding a keyboard. So if it is an output device, then how the circuit will be changing, okay, how the working principles of this parallel port will differ from the input principle, we'll observe that. Yeah? Okay, okay students. So we'll meet with the next topic, the next video. Thank you, students.